Number 2. So we're continuing our test prep for Unit 7. Number 2 says to sketch this without using a calculator. So we're going to start without a calculator, but when we get there, you can take your calculator from the charging pods. All right, so let's write it down. Can we do this together? And let's assume that you need my support here. So I need to know how to graph this with at least 2 points. There's also an asymptote, and to understand concavity and different things like that. So step number 1, I need to know what the parent is of this. Negative 2 e to the negative x plus 1. What would the parent look like? Parent is the most basic form of this type of equation, and it's e to the x. Tell me 2 points on the parent and the asymptote. 0, 1. 1 and e. What's the asymptote for an exponential? Now we're going to transform this to negative 2 e to the negative x plus 1. So do you know how to do transformations? So begin. In the exponent, it tells you how x changed. So it went from x to negative x. So what am I going to do to each x coordinate to change it? Divide by negative 1. Let's do it. 0 divided by negative 1 and 1 divided by negative 1. All right. Next, the y's. Do you see something in front and behind the y that will help you?
Yes.
So we're going to multiply by what number? And then we're going to add 1. So 1 times negative 2, add 1. This is going to be trickier, but we can do it together. For this understanding, understand that E is about 2.7. We're going to actually use 2.7 to help us transform it, okay? Mr. Stephen, we heard that. So we're going to take 2.7. Do you know what negative 2 times 2.7 is? Just double it. And about negative 5 point. And then to negative 5.4, we're going to add 1. And that's about what? So we're going to go to about negative 4.4. Again, this is going to be easier again. 0 times negative 2, 0, and add 1, and it becomes y equals 1. All right, let's graph this. So first I'm going to go to 0 and negative 1. And then I'm going to go to negative 1 and negative 4. So approximate the next one. So negative 1 and negative, somewhere in here, negative 4.4. So do you have those 2 points? Where's the asymptote? At positive 1. So we do a horizontal asymptote at positive 1. And then the most important part is, these 2 points, how is this going to curve as an exponential? So can you see the 2 points as guiding you to the left? What direction is it curving to the left? Can you see that? As it curves up, what's going to happen is it's going to follow the asymptote. Now, that's an exponential with some transformations, right? Now we're going to answer the other question. So the first one is, could you tell me the asymptote and could you graph it? Yes, now, right? The next part are some calculus-like questions. Is this function increasing or decreasing? That's part B. So in part B, see, is this increasing or decreasing? And the answer is, from left to right, it is increasing. And the second part, is it concave up or concave down when you look at it? Is this frowning or smiling? So it's concave. So it's increasing and concave down. Part C is a full calculus question. Find the equation of the tangent line and the normal line when x equals 0. When we find the equation of a tangent line, what 3 things do I write down right away? X equals, y equals, and m equals. So the easiest one to begin with, x, obviously, it tells you x equals 0. Do you know what y equals when x equals 0? And the nice thing is you can actually go to your transform point, right? What does y equal when x is 0? Negative 1. And then where do I need the calculus? Is right here. How do I find the slope? at that point? What do I need to do? So let's write it down again. It's y equals negative 2e to the negative x plus 1. Can you tell me what the derivative is then? What's the derivative of negative 2e to the negative x plus 1? What's the rule for e? You write down what you see. Yes? Is there a hook in the exponent? What's the hook? And the derivative of 1 is just 0. This will be helpful. A negative times a negative makes it a positive. That just makes the next step easier. The next step is, what's the derivative at 0? So you take the derivative, and what number do you plug in? 0. Can you simplify this? Negative 0 just means 0. So e to the 0 is times 2. So what's the slope at that point? So when you're asked for the tangent line, do you now have the information you need to do the tangent line? So let's do that. So it's y equals, what's the slope? 2. It's okay to do this. Do you have to go x subtract 0? No. But it's nice to have a pattern, right? A template to plug into. And then what's the y coordinate? Now, what would the normal look like then? If that's the tangent, what would the normal line look like? So normal means perpendicular, right? And I like that you remember this. Perpendicular means opposite and reciprocal. So the opposite of positive 2 is, and then the reciprocal is 1/2, and everything else stays the same. So it's just the slope that changes. Beautiful. Number 2 is done. I'm going to change the page to number 3. Let's read what number 3 asks. So in number 3 it says, what does that little negative one mean? Inverse. So the derivative of the inverse at what x value is 2. That's what I'm finding. That's my goal, is to find the derivative of the inverse at 2. And what am I given to find that? Is a function. Not the inverse, but the function. And told that x is greater than 0. So we're going to start here. I'm going to start with the function given. So I'm going to start with f at x equals x cubed minus x plus 2. My goal is to find the derivative at 2 for the inverse. So it's good to remember this. What's the relationship between a function and its inverse to do with calculus? Is that they are what of each other? Reciprocals. Okay. Now, if the x value for the inverse, this is all I know, by the way, right? Do I know the y value that goes with it? No. Just the x value. So that means for the function itself, what do I know right now? The x coordinate is 2 on the inverse. On the function, what do I know then? Because they get inversed, right? Let's go back here. Do you know that f at x is a fancy way of just saying y equals? And now I know what on this function is the y value, which is 2. What do I need to solve for? What do I need to solve for? What don't I know? I don't know the x value on the function. I only know the y value. So I plug in the y value. I have to solve this. It's not as hard as you think. So I'm going to make it equal to 0. How do I do that? Subtract 2 to both sides. It's now equal to 0. What happens to the 2's over here? They cross out. How do I solve that? I solve it by what? So I factor out an x, and I have x squared minus 1. Do you know you could keep factoring if you're good? That's a difference of... So when I fully factor it, I then can get all the answers, right? X gives me what answer? 0. X plus 1 gives me what answer? And x subtract 1 gives me what answer? All right, I didn't write this down, but I should have at the beginning. What else did it say? X is what? So if x is greater than 0, I'm going to cross out. What's the only answer that's greater than 0? 1. So come back here. Now I know the point on the function. What's the point on the function? 1 and 2, and on the inverse would be 2 and 1. My goal is to find the derivative of the inverse at what? 2. But to find that, I'm going to take the derivative and plug in what? And then whatever the answer is, I'm going to do the reciprocal. So next I'm going to find the derivative. What's the derivative of f of x? 3x squared minus 1. What number do I plug in? 1. Simplify it. 3 times 1 squared, take away 1. So how does this give me the answer I'm looking for? So my goal is this. What's the derivative of the inverse at 2? What do I do with that answer? And it's done. Listen again, and it's not as bad as you think. You ready? You have a point. What's the derivative at that point? And the answer was 2. If you inverse it, that point is now what? 1, 2. And what's the derivative now? That's the relationship. So we found the derivative was what? 2. So the reciprocal is my answer for the inverse. All right, that's number 3. Huh? Yes?
Yeah.
Or no?
Yeah.
Okay, number 4. Sorry. You should always meet halfway. Y equals, right? 3 plus 2e to the x minus 1. Now, it says what? It's reflected across what? That is a complicated way to say something that you do know. And this is what you do know, is when you take a function and its inverse, they always reflect over what line? What they're asking for here is find the inverse. But they didn't tell you it. Instead of saying find the inverse, they say reflect it over the line y equals x, which is a complicated way of saying find the inverse. So, can we do that? What's the inverse here? What would I do first? Inverse x and y. Do you have the algebra skill to get y by itself? Step 1. Inverse of adding 3. Step 2. I want to get the exponential by itself. So what's in front? So step 2 is to divide. You have to divide everything by that 2, so a big fraction line. Now the exponential is by itself. How do I undo an exponential? What is the inverse of an exponential? And the answer is a logarithm. How do I write this as a logarithm? What's in the exponent? Write it down. What logarithm has a base of e? And then what goes inside? What's the last step to get y by itself? You just did it. That is the answer. So what's the equation of the new graph? And it's just that. You could just rewrite it over again. That's the equation of the new graph. So what was the indicator to know I needed to find the inverse? It talked about reflecting over the line y equals x, which is the definition of an inverse. So use the definition, and you have to know that definition to know you're finding the inverse. Number 5. Number 5 is practicing derivative rules. Number 6 is practicing integration rules. You still need practice, correct? So let's start. Number 5a. Write it down. Do you know the rule for ln root 3x? What's the rule for a logarithm? What's the rule? The rule is, what's inside? Root 3x. By the way, calculus and AP exam does not care if there's a square root in the denominator. You just leave it. What goes in the numerator? What's the derivative of that? What is it? So, what goes in the denominator? What's the hook? And if this was multiple choice, I guarantee you they would cross it out and the answer would just be part B. Write it out. Here we go. Do you know how to take the derivative? Do you know what rule I'm going to use here? Do you see x squared plus 2x? And you don't see it, but it's multiplying ln x squared plus 2x. This is called the product rule. When we did the quiz makeups, some of you didn't care to know that there was a product and a product rule in one of the questions when you did the quiz makeup. A few of you did know that there was a product rule. I'm telling you there's a product rule. What is the product rule? First times the... Now, how are we going to take the derivative of a logarithm again? You're going to listen. What's inside the logarithm? That goes in the... What's the hook? What's the derivative? That goes in the numerator. Plus, what's the next part of the product rule? The second times the, which is? Are we there? Now, if you needed to, if it was free response, you'd let it go, correct? So, let's say you had to simplify it for a multiple choice question. What could you do? What could go? X squared plus, what would that leave you with? Do you know what else you could do this to write the answer as? To like just make sure you have the algebra ability to match the answer in the multiple choice? What do you notice they both have? The first term and the second term. So what I can do is factor out a 2x plus 2, and what would be left? If you factored out a 2x plus 2, you'd be left with 1 plus ln x squared plus 2x. Just be aware that once you are done for free response, we're good. But do you have the ability to simplify it further to match one of the answer choices? And notice here, they both have a 2x plus 2. We factored out, divided out. So the first one, you're just left with 1. And the second one, you're left with ln x squared plus 2x. All right, part C. Do you know how to take the derivative of this? Y equals 2x times e to the x squared. What rule am I going to have to use? Not that hard, right? To recognize it and apply it. And it's not a difficult rule to remember. What is the product rule? First times the, what's the rule for e to the x squared? E to the, and then is there a hook? What would it be? Plus, they do not cross out, they multiply. What? They do not cross out. They multiply together. Then what's the next part of the rule? Second times the derivative of the first. That's a great answer in free response. Could you clean it up if you had to? 2x times 2x is 4x squared. And I'm going to ask you again the question, what do they both have in common? Both terms have a... So you could factor out an e to the x squared, and what would you be left with? 4x squared plus 2. Could you also factor out a 2? And you could also be left with this. So not only did they have an e to the x squared, they also had a 2 in common that you could factor it out so you could match a multiple choice answer. Part D. Y equals ln x. Could you tell me the derivative of that? You ready? First, you know what I'm going to do? If you do it this way, do you see what I did to the ln x? What's a derivative rule? What would I do? Negative 1 times 3, which is negative 3. Then what? You do ln x. You don't add 1 for derivative, but you subtract 1. Is there a hook? What's the derivative of the base? 1 over x. So you could clean this up by writing negative 3 in the numerator, and x, ln x squared, would be in the denominator. Look carefully. Do you see how negative 3 would be in the numerator? Ln x to the negative 2 belongs where? And 1 over x, the x also belongs where? so that you could clean the answer up. If it was free response, this is beautiful. For a multiple choice, could you rearrange it so you could see the answer choice and match it? Okay? E. What rule must I do for E? And the answer is the quotient rule. What is the quotient rule? What's the bottom? Log 2x minus 1 times what? Which is just, then subtract, now what? The top, which was, okay, what's the derivative of log 2x minus 1? It's a fraction. What belongs in the denominator? 2x minus 1, and it has a friend. What friend does it have? That's right, and Mr. Gertzen. So, that's true. Denominator, 2x subtract 1. Do you see how it's not ln ln? So if it's log, it needs a friend. And that friend is ln of whatever the base is. And you don't see it, but what's the base there? So do you see ln 10 and why it's necessary? The numerator's the hook. What's the derivative of 2x minus 1? The denominator, continue the quotient rule. Log 2x minus 1 squared. I'm not going to simplify it. Okay? All right, let's continue. F. One more derivative question. And then after the derivative question, then we're going to practice integrating. All right, how do I take the derivative here? So first, what is the rule for 3 to whatever? Don't even worry that it looks a little bit complicated. 3 to whatever, what's the rule? You write down what you see, 3 to the ln x squared, and it needs a friend. That's it, right? And then it has a hook. And what's the derivative of ln x squared? It is what's inside, which is x squared, and then the derivative is 2x, the hook. So there's a hook within a hook. So you could simplify this as 3 to the ln x squared, ln 3, and you could see it as just 2 over x. But honestly, this is where I'd like you to see it. Right there, be good. But do you see the rule? And do you see the hook? So for this one, not only did you need to know the rule for an exponential, but also for a logarithm for the hook. You needed both rules. Awesome. Okay, number 6. Can we integrate? All right, here we go. Write it down. What's your first thought when you see a fraction? Is that it could well be a logarithm, right? When you integrate it. What's the derivative of the denominator? What's the derivative of the denominator? I'm going to write down the hook that I need. So the derivative of the denominator, I'm going to put that there. Then, what number goes in front to keep it the same? What was it before? 2. What did it become? Now, we can integrate. So, the hook, where does it go? Goes. The number we start with is 2, and what's the rule? Ln e to the x minus 2, and don't forget the candy bars. All right, let's try it again. Part B. Can you integrate 4x squared e to the 1 minus 5x cubed? Start. Do you recognize where the hook should come from? From the exponent. What's the derivative of this, the exponent? It is what it says, so the derivative of 1 is 0, but then we write negative 5 This is e or just x? X, right? So let's try it again. So it's not e. So it's 1 minus 5x. So 3 times 5 is, so it should be negative 15x, what? Squared. And then we still write e to the 1 minus 5x cubed. Ignore this scratchy part. What fraction needs to be in front? What was it before? What did it become? Now we're ready. So the hook can go, what number am I going to start with? Negative 4 over 15. And what's the rule for e? Just what it says. And it's over. And don't forget the candy. This one does not mean the candy bars because the rule didn't become a logarithm. C. What's different already about C? Yeah, so the limits, make sure I write it down right, x squared plus 1, means there's be no candy at the end. Instead, there's going to be a substitution at the end, okay? When I see a fraction, you first should think of a logarithm. If it is a logarithm, then when you take the derivative of the denominator, the variables will match. So, when I do that, what's the derivative of x squared plus 1? What do you get? That's good, right? The variables match, but the constants I can work with. What was it before? And what did it become? Then, how do I integrate this? Well, the 2x goes. Write down what? 3 over 2, and what is it? Now, in this example, the candy bars, the bars part are redundant, and that's because no matter what number I put in for x, the answer will always be positive. So the bars aren't necessary, but they're not wrong if you put them in either. Okay? So always put in the bars. What number would I plug in first? So you'd write 3 over 2 ln, and it's 1 squared plus 1 equals, subtract. Write it again, 3 over 2 ln. Now what number do you put in? If you were asked to simplify it, would you know how to do it? So, what's 1 squared plus 1?
2.
And the absolute value of 2 is just, so 3 halves ln 2. This one, do you know what 0 plus 1 is? And you need to know that one of the properties of logarithms is ln 1 equals what? 0. So 3 over 2 times 0, I don't need the 0. The answer would just be 3 over 2 ln 2. That this is just 0. Kit Kat? Part D. Thank you. If it's going too fast and you need to tune me out, you can. Go back to the video, right, to do the work you need to do. But we need to get that video so you can study, right, tonight and tomorrow night. Let's try again.
Subscribe to.
Yeah. All right, here we go. How do I integrate this? My first thought is a logarithm, but do you know why it's not a logarithm, what the indicator is? The indicator to know it's not a logarithm is that 3. Do you see that? It's a logarithm if the exponent in the denominator would be 1, because that becomes a negative 1, and when you add 1, that's 0, it's special. But this one, that 3 means it's not a logarithm. It's just the anti-power rule. When I take the derivative of the base, what's the derivative of x squared minus 1? 2x. So you write it down. What was it before? What did it become? So when I integrate this, the 2x can go. 4 divided by 2 is just 2. And then this is just the power rule. So the anti-power rule is add 1, and then what? Divide, and we're integrating from negative 2 to 0. We're going to make our life a little bit easier. The 2's cross out, and it's just what in front? And then, can you do the substitution at the end? What gets substituted in first? 0. Subtract, and then what gets substituted next is negative 2. And we're just going to let it go. So first you plug in 0, subtract, then you write it over again, but instead of 0 you put in negative 2, and it should be negative 2 squared. Awesome. All right, that's practicing derivatives and integration. Number 7. Number 7, they give you a function. I'm going to write it down. If you feel like you are losing your energy, don't act out loud or make other people distracted. You got to deal with your own mind and body as you prepare for a calculus exam. Okay? So write this down.
Words of Wisdom by Mr. G-Man.
Thank you. I know this well because I parent toddlers, that when someone's tired is when they act the worst. And they act out when you're tired. You get hurt when you're tired. It's never good when you're tired, right? So when you don't get the sleep you need the night before and you're trying to prep for a calculus exam and there's a lot of content being thrown at you, you then react negatively and your behavior becomes, you act out. You don't listen to me, you talk to somebody, you distract somebody, all of that toddler behavior, right? And it gets to a point is if you didn't get the sleep you need and you're a little tired, you're going to have to give yourself a time out, right? And then when you're ready, you come out of the timeout and you keep working. But don't drag other people down. Number 7, you're given a function and you ask for what's the largest interval that it contains an inverse function. Now, one of the definitions of inverse is that the function has to be 1-to-1. Meaning a 1-to-1 function only increases or only decreases. To answer this question, step 1 is, I'm going to take the derivative, because I need to know where the maximums and minimums are. We're going to do that together right now. Power rule, 3 times 2/3. The 3's cross out and you just get 2 and subtract 1 to the exponent. Again, 2 times 1/2. The 2's cross out and you have negative x. Negative 6x, take the derivative and you get negative, and the derivative 1 is, now I need to make this equal to 0. I need to know where the maximums and minimums are to know where it's increasing and decreasing outside it. So I'm going to make it equal to 0. It's a quadratic. We're going to solve this quadratic by factoring it. 2 times negative 6 is, and in the middle is negative 1. What two numbers would fit? Negative 4 and 3. I'm going to go back to the equation. I'm going to take out negative x and put in negative 4x plus 3x. And I'm going to factor by grouping. The first two terms, what do they have in common? And what's left over? X minus 2. The next two, what do they have in common? And what's left over? And now it's done. Notice they share a factor, which is x minus 2, and what's left over is, so if I solve the first one, what does x equal? The first factor gives me the answer 2. The next factor, can you subtract 3 and divide by 2? And get negative 3 over 2. Draw a number line. This is a polynomial, it's continuous, but there are two places that might have a maximum or a minimum, and that's at negative 1.5 and at 2. So this is a first derivative number line. What's a number? Remember, this is the derivative right here, in fact. See this right here? The factored form? It might be easier to use the factored form. What's a number smaller than negative 1.5? How about negative 1 billion? If I put in negative 1 billion, the first factor is going to be negative. The next factor is going to be negative, and a negative times a negative is. So what's happening from negative infinity to negative 1.5? It is increasing. Now, what's a number between negative 1.5 and 2 that's easy? 0 means negative. 0 means positive. So a negative times a positive is. So between negative 1.5 and 2, it is now decreasing, which means we just found that negative 1.5 is a maximum. Pick a number bigger than 2. 1 billion. That means positive and a positive, which is positive. Which means at 2 we have a... So at what interval would be the biggest interval to have inverse? It's a bit of a mind thing again. Remember we talked about like infinity and negative infinity, or theoretical and it expands forever kind of idea. But mathematically, can you see why the bigger interval goes from negative infinity to negative 1.5? Do you know why technically that's bigger? Wherever infinity, here it's a bigger interval because it goes to negative 1.5. This one's a little smaller by 0.5. But it's still kind of mind-blowing. But do you understand the concept of intervals? About the first derivative test and how it helps us understand one-to-one functions. All right, number 8. Number 8. It says no calculator. I haven't let you use it. We're going to use a calculator. Not yet. All right, here we go. Write it down. A, it says, first find the domain. What's the domain of x squared times e to the x plus 1? And what you're looking for is there any number that would make it undefined? Can I put in a negative number and is it okay? Yes. Can I put in 0 and is it okay? Yes. Can I put in any positive number? There's nothing that makes an exponential or a polynomial undefined. It's all good. So you're right. Abel is right on. All real numbers. Guessed right. Right? B, where are the intervals of increasing, decreasing, and concavity? So to do B, can you take the derivative? What's the derivative of this? What rule must I follow for the derivative? Product rule, which is first times the... Now, the hook here, what's the derivative of x plus 1? Do I need the 1? No. Plus the second. And the derivative first is, this is going to be helpful. We're going to factor it. What do they both have in common? E to the x plus 1. What's left over? X squared. What's left over? Now, what I'm going to do is make it equal to what? 0. Now, if I take the first factor, e to the x plus 1, and make it equal to 0, there is no solution to this. Do you know why? Because e to any number will always be a positive number. It could never equal 0, so there's no solution there. How about the second one? X squared plus 2x. If you make that equal to 0, can you solve it? How would you solve it? So if you factored it, what would the two answers be? So I'm going to draw a first derivative number line. What numbers am I going to put on here? Negative 2 and... Make sure they're in order, right? From small to big. We're going to plug into this. Right up here. Do you see this? Yes, the whole thing. But recognize no matter what number you plug in for x for the first part, that will always be positive. And it's the second part that could be positive or negative. Yes? Thinking together? What's a number that's smaller than negative 2? Negative 1 billion. The first one is going to be positive, right? What's going to happen to negative 1 billion squared? That's a positive number. 2 times negative a billion is negative, but the square is going to be overpowering, right? So it's clearly going to be a positive times a, which is... What number is between negative 2 and 0? Negative 1. The first one's always going to be positive. Negative 1 squared, 2 times negative 1. Is that going to combine to a negative answer or a positive answer? So a positive times a negative is, so between negative 2 and 0 it is decreasing. What's a number bigger than 0? And you can tell, no matter what, right, it's going to be increasing after 0. So what did I learn? What intervals is it increasing? Negative infinity to negative 2. And that creates what, by the way? A maximum. Where is it increasing also somewhere else? From 0 to infinity. What's going to happen at 0? A minimum. Where is it decreasing? From negative 2 to 0. Second part. Concavity. What do I do to find the concavity? So the first derivative, just to remind you, was e to the x plus 1 times x squared plus 2x. What would the second derivative be? Could you do it? This again would be the product rule. What's the first? E to the x plus 1 times the derivative of the second plus the second times the derivative of the first. Again, you're going to factor out e to the x plus 1. You get 2x plus 2. What else do you get? Plus x squared plus 2x. So I'm going to clean that up a little. Combine like terms, you have x squared plus 4x plus 2. All right. What do I do next? Make it equal to 0. E to the x plus 1. If you make it equal to 0, there is no solution. How about x squared plus 4x plus 2? Could you solve it? How would you solve that? Any ideas? I'm going to do this just for fun. First of all, diamond doesn't work, you can't factor. You could do the quadratic formula, but just for fun, we're going to do this. We're going to complete the square. You ready? Let's pretend it's been like a million years, and you just want to listen to me and remind yourself how to complete the square. You ready? So step 1 is, I'm going to take the constant, I'm going to subtract it to the other side. See this constant? I subtracted it to the other side. I need to know what number I add to the left side to make that a perfect square. So there are two ways to think of this. One way to think of it, which is the easiest way, is to take the b, which is what number? 4, and you're going to do two things to it. You're going to divide by 2 and square it. So one of the little formulas that completes the square is b divided by 2 squared. What is that? 4 divided by 2 squared. What number do you get? So what am I going to add to both sides? So on one side, I'm going to factor it. It is x plus 2 squared. Two numbers that multiply to 4 and add to 4, right? On the right side, negative 2 plus 4 is 2. To solve it, we're going to square root both sides. So we have x plus 2 equal positive or negative root 2. There are two solutions here. And then the last step is to do what? Subtract 2. So we have two answers. One answer is negative 2 minus root 2. Just know that that's approximately negative. Root 2 is a little bigger than 1, right? So it's like negative 3 point something, right? Probably a little bigger than 0.2. But we're just estimating it. And negative 2 plus root 2 is like the other way. It's like negative 2 plus 1 in a little bit. So it's like negative 1 point something. So when I estimate the concavity, I can use those two numbers. So I'm going to come back up here a little bit. I'm going to draw a second derivative number line. And we're going to use approximately negative 3.2 and negative 1.8. I'm going to write down the second derivative again. The second derivative is e to the x plus 1, x squared plus 4x plus 2. Okay, we are going to pick a number here that makes sense to us. Do you know that e to the x plus 1 will always be positive? So, what happens when you put in negative 1 billion? What do you think the answer is going to be? Positive, right? Because negative 1 billion squared is a big positive number. So from negative infinity to like about negative 3.2, it's concave up. What's an easy number between negative 3.2 and negative 1.8? Negative 2. If I put in negative 2, is the answer going to be positive or negative? So it's 4 times negative 2 is negative 8. That's bigger than 4 plus 2, right? This answer is going to be negative. If you put in positive a billion, it's going to be positive. So what did we learn? From negative infinity and I'm going to use the exact answer. So from negative infinity to negative 2 minus root 2, this is concave up. Also, from negative 2 plus root 2 to infinity, it's also concave up. Both of these are concave up. The only spot that's concave down goes from negative 2 minus root 2 to negative 2 plus root 2. That one is concave down. It says find all the extreme values. So we found concavity and increasing and decreasing. Extreme value means concave, maximum and minimum. Where is there a local maximum? What x value would I use? And you would plug negative 2 into here, and you'd find your local maximum. Where would the local minimum be? What number would you use? 0? And by the way, if you go 0 squared times whatever, the answer is going to be 0. So when you plug in 0, the answer is 0. So where is there a minimum? At the origin. 0 and 0. Oh, sorry, this is the, not the maximum, but the, so this one's the minimum, and this one's the maximum. Where does the concavity change? So we have a point of inflection when x is, I'll use negative 3.2. So at negative 3.2, you'd plug that in. And we also have a point of inflection at negative 1.8. What would the sketch look like? What would the graph actually look like? Oh, it said find all intercepts too. Do you know how to find the intercepts? If you plug in 0, do you know where the y-intercept is? If you plug in 0, the answer is 0. That means 0, 0 is also a x-intercept. And that's it. There's nothing else that makes it 0. So what point do we know for sure on this graph? 0, 0. Now, we're just going to do some estimating. At what x value do we have maximum? Somewhere here at negative 2 we have a maximum, right? No. Somewhere here we have one. Now, it's going to be increasing, right? Can I tell you something else? Shh. Do you know it's impossible for y to be equal to a negative number? That it's impossible for this to give you a negative answer? Because x squared is always positive, and e to the x plus 1 is always positive. The answer is always going to be positive. Do you know what that means? We actually have like an asymptote over 0. So it's increasing up to this point, right? And then what happens after it increases? It decreases. So we're increasing. Somewhere here it's going to change concavity. So it concave up, concave down, same thing here. And then the last part is we know it's concave up to the right. And you have your maximum, your minimum, and you understand some concavity changes right there, right? It's concave up, it's concave down, and then it's concave up, and you have your maximum, and you have your minimum, and you know there's nothing in the negative area, right? And it's done. All right, number 9.
Jesus Christ, Almighty.
That was a good one, right? Thank you. Sometimes I just want you to be impressed by me. So, number 9. Okay. Shh. Hey, do you know what the graph would look like for this if you had to sketch this? So, it starts with the parent. Do you know what the parent is? Just ln x. And 2 points on this parent are 1, 0, and the base and 1. And the asymptote here is x equals 0. Now, when I look inside, what's the inverse of subtracting 2? So we're going to add 2. E plus 2, we'll figure that out in a second. That's about 4.7. And then the asymptote now is where? Instead of at 0, it's at 2. What do the absolute value bars do on the outside? It makes any negative value, makes it positive. So 0 will stay 0, and 1 will stay 1. But we know when we graph this, we have negative answers. All those negatives will be reflected up. So we're going to graph this. We're going to start at 2, because what's going to happen over 2 is the asymptote. We have a point at 3, 0. And we have a point at like E plus 2, I said is about 4.7, something like that, and 1. So somewhere here at about 4.7 and 1, you have the second point. Do you know how normally you would draw it where it follows the asymptote and curves up?
Yeah.
But the absolute value says any of these negative values are actually going to be reflected up. So instead of drawing it like this, right, this part that would be below gets what? Reflected up. And it's done.
Shakalaka.
What would happen if I switched it around? What happens if the absolute value bars are inside? How would you graph that? What would this do?
It would be plus 2.
Now, I'm going to tell you, it is going to be reflected. So, do you know like what we just did? We have a point 3, 0, right? So at 2, we still have an asymptote. We still have a point at 3, 0. And we still have that point at 4 point whatever and 1. We have this part, right? And when the x's are positive, right? This one, the absolute values are on the inside, which means you could have a negative answer. But because the values are on the inside, this gets reflected over the asymptote. And on the other side, you have a reflection of this on the other side.
Whoa, dude.
So the only value that x cannot be is 2. All the other values, because of the absolute value, makes everything positive inside the logarithm. So there's only one bad answer, which is 2. So you draw the positive and then reflect it over for the other side. Number 10. Let's do this. The doozy. This one's not bad. Hey, do you know how to integrate 1 over x minus 1? Do you see the fraction? And it is to the exponent 1. So guess what this is? It's a logarithm. What's the derivative of x subtract 1? It's ready to go. So it's the absolute value of x minus 1. There's no candy. Instead, we integrate from 1 minus e squared to 1. Oh, it's not 1, but what is it? That's going to be important because what did I just realize if I use positive 1? It'd be 0, and you can't have a 0 there. All right, so I recognize my little error. So it is definitely negative 1. Which one do I plug in first? And then what do I plug in second? Now, if you're asked to simplify this, know that negative 1 take away 1 is negative 2, but the absolute value of negative 2 is 2. Here, 1 minus e squared, subtract 1. 1 take away 1 is, and the absolute value of negative e to the square is just e squared. So the absolute value of negative e squared is just e squared. Do you know where that 2 could go to? And do you know that ln e is a property? Ln e is just equal to 1. So the answer is ln 2 minus 1. So a property, the exponent can be written in front, and ln e by itself is just equal to 1, and now you have a simplified answer. Yes?
Isn't it ln 2 minus 2?
Ln 2, where are we looking at?
On the because 2 times 1.
Oh, you're right. 2 times 1 is? Got it. Ln 2 minus 2. All right, 2 left. You ready? Number 11. Remember, if you're tired, give yourself a timeout. And you can come back to the video when you're ready.
I just asked you to repeat it. I asked you for a breather.
Yeah, you do it. I'm not taking a breather. I got 10 minutes left. So,
You don't do it.
let's go.
Let's get it. Say it. Say it.
Yeah. Let's get it done. So, to find the average value, I'm going to remind you how we do it. We integrate using these bounds, 0 to 1, and we integrate what the function is, 3e to the 4x subtract 1, and then we divide by the difference of the bounds, which is 1 take away 0. So do you see the setup for average value? It's an integration question, and the interval gives me the bounds, and then you subtract the bounds for the denominator. We'll clean this up. Really, 1 take away 0 is just 1, and when you divide by 1, it doesn't change the numerator. So I can just write this down, they're equal. So understand the setup and that you can simplify it. How do I integrate e? Well, to integrate e, where is the hook? Where does it come from? And the derivative of 4x is 4. That's the hook I need. What hook was there before? And what did it become? Now we're going to integrate. So what's going to be in front? And when I integrate this, the hook can be gone, and the rule is just e to the 4x, and the derivative of 1 is just x. So we integrated it, just separated it into 2 parts. And the integration of 1 is just x, and then I plug in 1, and then I plug in 0. So I have 3/4 e to the 4 times 1 minus 1, and then I subtract. Be careful, when you plug in 0, the answer is not 0, because e to the 0 is equal to 1. So just plug in 0, and you won't make a mistake. And that's a great answer. So first you plug in 1, subtract, then you plug in 0, and make sure you use parentheses after you subtract. All right, the last question is number 12. Go ahead. All right, number 12 says, a rectangle has 2 sides, one along the x-axis and the other along the y-axis. So, I'm going to do this in a different color. So when I draw a rectangle, what did it just tell me again? I get if you're tired, and you give yourself a timeout and come back to it later, this will be a question on your final exam. So the rectangle has one side along what? The y-axis, another one along the x. Now, it says there's a corner or vertex point that follows along the curve y equals x times e to the x. To get a sense of this, this is a curve. If I plug in 0 for x, what answer do you get? Is 0. You recognize it's not going to be negative? If I plug in 1, 2, 3, what's going to happen to this curve is it's going to increase somehow here. I actually don't need to know exactly the curve, but I need to know it increases, right? And if you take any point along this curve, you would then make your rectangle from that point. Do you see that? That means a point on that rectangle is going to be the x-coordinate and x times e to the x. That's a point on that rectangle. What I want to find is, I want to find in such a way, where it says here, it moves along there, in such a way that x increases at a rate of 1/3 centimeters per second. It says, how fast is the area of the rectangle increasing when x equals something? That gives me my indicator. Where am I starting? Area. How do you find the area of a rectangle? So the length and width. The width is always going to be what number? Or what letter? X. And you know what the width, the height of it is going to be? Or the length of it is always going to be? The y coordinate. It's going to be x times y. Do I know what y equals? Y equals x times e to the x. You have an area formula. Do you know the area of a rectangle? X times y. And do you know what y equals? You plug it in. Yes? So we have a formula. And x times x is x squared times e to the x. If I want to know how fast the area is increasing, that's calculus. That means I need to take the derivative. So what's the derivative here? So it's the product rule. What's the first? Times the. So the first is x squared times the derivative of the second. Now the derivative of x is just 1, but we need the hook dx by, every time you take the derivative of x, we need the hook, because we're taking it with respect to time. Now, the second part of the product rule, plus what? The second times the, and every time you take the derivative of x, like x squared is 2x, we need the hook, what? dx by dt. So can you do the product rule here? Understand that 1/3 is what? How fast x is moving, correct? It's increasing, so 1/3 is positive. That represents how fast x is increasing. So wherever there's a dx by dt, what will I put in? Good. What number will I plug in for x? What does it tell me in the question? What does x equal? Ln. In the question, what does x equal? So if I want to know this answer, I don't need to simplify it at all. Don't simplify it. Wherever there's an x, what am I going to put in? Ln 3 e to the ln 3. And then what do I put in for dx by dt? 1/3. Continue. Plus e to the ln 3 to ln 3. And then dx by dt is 1/3. And that, as beautiful as it looks, is it. Oh, look at that. Way too good at timing. And that's units squared. Okay? I guess. All right. So there's your test prep. I will put a blank copy so you can print out a blank one, and then write out the question if you need to. Okay? Mr. G Math. Abel. Over now. Right?